breaking right down to that list. So, our next one should be power goals and when to add sensors. I think those are both one and the same as far as when you are working to push your car harder, you should have more data input. Um, Short and sweet, that's exactly how I define power as far as when we should be pushing to certain things. First off, I'll say generally, I don't use a knock sensor for rotary. If you knock once, you're usually done. You're done. There's no in between. It's go, no go. So knock sensors I usually don't believe in on rotaries unless you have a very, very good processing for said knock sensor. Um, believe AEM is the one that I can think of off the top of my head. Mtron, Motec. Um, there are quite a few that have an excellent knock floor that you can see very well in a data log. You're saying, okay, here's the knock floor. You induce a little bit of ignition at a low RPM, and you're like, see, I can hear it, I can see it. That is a knock event. And then you're building that per RPM per load. It ends up being, in my personal opinion, more dangerous to do that than not doing it at all. And taking maybe a similar engine package, truly finding MBT on it, and then backing it down by a factor of safety for a given fuel, a given climate, so on and so forth. And a lot of your needs for, let's say, Joe Blow's setup is going to be different across different platforms. Drag racing guys aren't going to care about getting 60,000 miles in their motor before rebuild. You know, you've got guys that are in Texas that have 100% humidity and 120-degree air temp, like just astronomical heat. So all these builds have to be tailored to such. Um, I normally define power goals based on the needs, the area, and the budget. So if your budget allows any engine over 8,500 RPM, 25, 26 pounds of boost, I would say go to CDI. CDI is now going to be making your spark event in a zero point 0.2 millisecond time versus like a smart coil is about 3.2 and varying, of course, due to the voltage and the ECU's control for the delay. I find that on a rotary, ignition 1As are great for 8,000 RPM setup under 25 pounds. It's the right way to go. I think that the amperage rating beyond that is now a loss. So if you're trying to pull out, let's say 5.2 milliseconds on a coil, you're going to be much more likely to harm that coil by overdwelling it to keep up with boost to make it a clean spark event. You're just running out of duration because the rotary engine itself has half the duration of the spark and fuel event compared to reciprocating engine. So it makes sense to have something that is a shorter spark duration. The alternative, which I know Shane T has showed, and there's been a few members, I think it was Ian or something like that. There's a company called New Eagle, and they take almost like an Audi R8 style coil, but it looks just like an Ignition 1A, and it'll make 105 millijoules at, I think it's about 2 milliseconds of time. The downside of that being that it's drawing 25 amps per coil to do so. So you've got 4 coils. Clearly you're not going to go all at the same time, but you could have a very short duration when you're at 9,000 RPM in which your system is being pushed hard as far as the electrical draw. And again, this would be something, a CDI, even something badass like a Fuel Tech that has CAN bus and all that stuff to report back to the ECU for limp modes, for any sort of engine protections, diagnostics, stuff like that. That thing's only pulling 50 to 60 amps worth of power from the setup. So a lot of these cars are getting older. Um, the ignition, if it's pulling half of what the total amperage rating is, like it's kind of a lot. So just something to think about. CDI is definitely going to clean everything up in the top end because it's making all the energy of the spark event happen in a very short duration of spark. You're losing out in like the MSD effect, which is the multi-spark discharge. That's MSD. That's what it stands for. So you're losing out there on CDI. But realistically, once you start the kernel of a combustion event, it only needs to have one, and then it continues across the combustion chamber. That's the whole point. And you guys can see these in slow motion videos. It's been explained in a lot of different engineering books. It's very simple to think of it that way. So CDI is always the choice, the right choice, and that will dictate your power goals because the CDI is now ignition 1A is $72 a coil, and a CDI entry level from M&W, which M&W has a very, very, very clean ignition discharge for CDI. The entry level one of those is about $1,200. So you're talking $350 to $1,200 just as the entry level to the entry level. I just think that that's kind of going to be your first main choice. Do you want an engine that's going to be revving out to the moon? Do you have the balancing to handle that? Do you have the oil pressure to handle that? Because these engines don't have any sort of oil main, anything to control beyond a film of oil. And the next thing, of course, being your fuel choice, right? So I've seen exactly where pump gas can go, where pump gas and water meth can go, and where E85 can go. I've yet to really tune a methanol car, and that's something I'm looking forward to next year. I definitely think we'll have some drag racing stuff in the books, so I can kind of explain to you guys what happens when we have a mechanical limitation, which is what I'm beginning to see on E85 because the fuel isn't a problem. But for methanol stuff, you're always mechanical limited if you tune the thing right and you don't hydrolock it and doesn't crack an iron because of hydrolocking. So let's get back to specifics of power goals versus budget. We can break this down into ignition, like I did, fuel systems, we can say turbocharging, supercharging, NA, like all of that stuff will always contribute to your decision of if you have a $5,000 budget, a $25,000 budget, whatever it is, we can take a moment and say the best path to get to here might be this stage for this turbo, then this stage for this turbo. And normally I'm one to hate staging of anything. It's very simplistic, it's very dumb to think about. But to simplify for others, if I could say, like, you want to have 350 horsepower, OEM plus, and you want it to last for 65,000 miles between rebuilds, no problem, here's a package to do that. You do like a modern set of like FIC 1000s on all four, and you would have a 62 millimeter turbo on the compressor side, and you're running pump gas on a wastegate spring of 12 pounds. There's your 350 horsepower all day long, and it has no problems doing that. Super clean. I'd get the AFRs and spark would be most likely a factory system if your ECU can handle it. For the FD-RX-7 guys, on a Haltech, I've tested the factory ignition to handle about 425 wheel horsepower. I've pushed that same ignition up to about 460, and with the factor of safety that I would want, I think that 425 is a good range. The factory FC ignition does not work on a Haltech, but it works on Adaptronic and it works on a few others. I'm pretty sure it does not work on Link, so I need to double check that. And I'm almost positive it doesn't work on Fueltech. So the wasted spark of the FC on an Adaptronic, for instance, I've tested well over 450 horsepower. Those are very strong ignitions compared to the FD stuff. So that's kind of where you can start pricing out. Like, do I really need to have this Ignition 1A setup? Do I really need to have this M&W or Fueltech CDI? That's going to be kind of your first variant of what you're aiming for. The next thing, of course, is your engine is going to be based on power output, not boost pressure. That's kind of a misnomer in our tuning industry. So if I were to have a GTX 4202R at 14 psi and it's making whatever 465 horsepower versus a EFR 7670, the EFR can probably run more boost because the cylinder pressure, the combustion pressure itself of that system can handle more boost to make the engine's tolerable level of power. So if the GTX is doing 14 pounds and the EFR might be able to do 18 pounds because realistically our pump gas can go further on a smaller turbo setup because the combustion pressure is lower. My phone is going off like crazy. I'm sorry, guys. I've had 3 phone calls during this. So the combustion pressure is what we are dictating. So there are actual sensors. They're about $5,000 for the controller and sensor to have as a spark plug replacement. It puts a hole into the spark plug and it has a pressure transducer that works at incredibly high speed to measure combustion pressure event. And this is how we can truly define the rotary and where it's able to handle certain pressures and how the pressure waves are reacting inside the engine. Gale Banks did a phenomenal video on this. I'm not sure if you guys ever saw that, but definitely go check that out. He did it on it was the LP5 Duramax, one of the first videos he did of that on DynoCell number 2. Sure worked out great. So he's able to map out cylinder pressure maximums and then say, he'll refer it back to GM and say, here's the limitations of this, and then here's what needed upgrade to handle more. So back to subject, power goals and budget. The budget these days, we have to deal with inflation. We have to deal with crazy prices on these cars becoming more limited because those who own them are most likely going to keep them for the rest of the vehicle's life. The power goals, I was saying to put it in tiers. I think that like 400 or 350, then kind of like 475, 500, and then like 600, 575, something like that, and then upwards of that. And kind of every 100 really makes a lot of sense because given a particular turbocharger and a goal, like if someone wants to have their power band very narrow and peaky, or a boost that's a progressive curve to where it's gaining boost as you go up in RPM. Drag racing, for instance, is exactly like that. It's just more so of what your needs are. Sorry, these notifications keep popping up in front of me. It's driving me nuts. Of what your needs are to figure out your build and your budget. So if someone says, hey, I've got $5,000, I can tell them exactly where that needs to be distributed to identify an ideal system. The sensors and the data that we're getting from that will be dictated based on your budget. Like, you can only stretch things so far. And it's really an interesting thing about, I've had this conversation with a few clients, is people are forgetting that you might have all these parts that are like top tier or whatever they are, but if they don't work in synergy together, then you're kind of shooting yourself in the foot. And then if you don't have someone who's able to take these parts and build them with synergy, you're going to be missing out on, like, tuning should be a sizable budgetary thing that you're setting aside when you go to build the vehicle. Because just like your wiring guy is putting in a bunch of hours for this stuff, your mechanical guy is putting in a bunch of hours for this stuff, your tuning guy is putting in a bunch of hours for their stuff. And the way to extract a given power is definitely not by rushing it. You're going to take baby steps. You're doing the simplistic stuff first. You're going through your sensor data. You're saying, hey, you know what? We're having a weakness here. We should change this. And there's a lot of small nuances in that tuning aspect to where it shouldn't be like, oh yeah, I can go to Bro Tuner down the street and he's $300. That's right. He's going to run your dyno, or run your car on the dyno for 3 pulls. It's going to run like ass in the street. And yeah, or it might work wide open throttle, and then it can't work for the rest of your drivability. So it's useless for time attack, for street, for anything that's enjoying the car. And we can do those slam bam together shits, but you get what you pay for. And that goes for everything in life, whether it's hardware, software, mechanical work, whatever it is, you're getting what you put out. So this has already gone way longer than I thought. 17 minutes. Sorry, guys. But power goals versus budget, there's a lot to cover. It's like a 3 video breakdown, realistically. So, ignition. Fuel system, that's easy to calculate out. Budget and goals, that's pretty much basing everything off your turbocharger. So, if you have the budget for a better turbocharger, that should be your number one priority. Everything about a modern turbo makes a modern build a lot better. If you had a goal for 475 horsepower, man, if you put a chunk of your budget on a brand new turbo, you get there way easier because they're so efficient on so many different platforms and levels. So that's where your priority should be. So, we'll end on that note. The sun's about to ruin the rest of my videos, so I'll probably end this very, very soon. So, take care. See you guys in the next one.